This is the fifth video in the Chemistry Key Skills revision tutorial series. In this video, we will be looking over moles and concentration. In this video, we will look at what is meant by 1 mole of a substance. We will look at the number of moles of a substance, how to calculate this using mass and molecular mass, and we will calculate the concentrations of solutions in grams per dm cubed. We will be looking at 2 big questions today. Firstly, how many moles of CO2 are there in 132 grams? And 58.5 grams of sodium iodide is dissolved in 0.5 dm cubed of water. What is the concentration of this solution? Here we have 4 different quantities of 4 different elements. 32 grams of sulfur, 56 grams of iron, 12 grams of carbon and 24 grams of magnesium. The question is, what's the link? The link is that each of these is 1 mole of that specific substance. So what do we mean by a mole? Well, the mole is the name given to a certain number of particles. It is also equal to the relative atomic mass in grams. Instead of writing out this, we just write mole. So the relative atomic mass in grams of carbon is 12, so therefore a mole of carbon is 12 grams. Simply put, this means that 1 mole of atoms or molecules of any substance will have a mass in grams equal to either the AR or the MR of that substance. We can work out moles due to Avogadro's constant. This is Avogadro right here. Avogadro's constant states that there are 6.02 times 10 to the 23 particles in 1 mole of any substance. 6.02 times 10 to the 23 is equal to this number. This is why we write this in standard form as 6.02 times 10 to the 23. This is a huge number of particles. We can use this number in order to work out the number of atoms in a specific number of moles. For example, how many atoms are there in 3 moles of hydrogen gas? First, we multiply our number of moles by Avogadro's constant, so 3 times 6.02 times 10 to the 23, which gives us 1.81 times 10 to the 24. As hydrogen goes around as a diatomic molecule, it's H2, as we've looked at in the previous video. This means we have to times this number by 2, giving us a final answer of 3.61 times 10 to the 24 to 2 decimal places. It's important to give your answer in standard form. This is where having a scientific calculator in the exam is essential. An essential calculation in chemistry is being able to work out mass, moles, and relative atomic mass, or MR, as we've looked at it previously. That gives us this equation, where we have mass equals moles times MR. We can rearrange this to find out moles, where moles would equal mass over MR. And finally, we can work out MR by doing mass divided by moles. It is also important to remember the units of these. So mass is in grams, moles is in moles, and MR has no units. This is an essential equation to remember for chemistry. Using the equation on the previous slide, we're going to look through a few examples. So first of all, we have 1 mole of carbon dioxide, CO2, and we are given its MR, which is 44. We can work this out using the atomic masses on the periodic table. If we take our mole, which is 1, and our MR, which is 44, moles times MR gives us a mass of 44. If we have 2 moles of carbon dioxide, we will then have a mass of 88 grams. I want you to have a go at working out the rest of these questions. Okay, so for question 3, we have 0.5 moles. 0.5 moles times 44, our MR, gives us a mass of 22 grams. For question 4, we need to rearrange slightly. So this time we have to work out our moles. Moles equals mass divided by mR, so 4.4 grams divided by 44, which gives us a value for our moles of 0.1. Again, for the next question, we have 1 mole and an mR of 18, so moles times mR gives us our mass of 18 grams, before again needing to rearrange. Again, we need to do mass divided by mR to give us our moles, so 4.5 divided by 18, giving us 0.25 moles of water. For the last 2 questions, we've been given 2 made-up elements, and we have to work out their MR. Obviously, usually we would use the periodic table for this, but this is showing that we can rearrange this equation. So this time, to work out our MR, we need to do the mass divided by the moles. So we have 73 divided by 2, giving us an MR of 36.5. And then finally, we have a mass of 40 divided by 0.5 moles, giving us an MR of 80. We can also extend this out further by working out the number of atoms in a certain number of grams of a substance, once again using Avogadro's constant, but combining it with moles equals mass over mR. For example, how many magnesium atoms are there in 48 grams of magnesium? The first thing we need to do here is convert that mass into moles using our moles equals mass over mR equation. From the question, we've been given the mass of magnesium, which is 48 grams. Using our periodic table, we can find out that the AR of magnesium is 24. Meaning that we need to do 48 divided by 24. This gives us 2 moles. As we now have the number of moles, we can multiply this by Avogadro's constant. So we do 2 times 6.02 times 10 to the 23, giving us an answer of 1.204 times 10 to the 24. You can also be asked to work out the concentration of something. Before we look at concentration, it's important to be able to use volume. In chemistry, we use dm cubed. However, you are often given your volume in centimetres cubed in your question, so you need to be able to convert between them. So 1 dm cubed is equal to 1,000 centimetres cubed. So we're going to practice converting these. So 1250 centimetres cubed would be 1.25 decimeters cubed. In order to convert, we will divide this by 1,000. To convert from centimetres to dm cubed, again we will divide by 1,000, so 1 centimetres cubed is equal to 0.001 dm cubed. To convert from decimeters cubed to centimeters cubed, we times by 1,000, so we have 0.056 dm cubed, which when we times it by 1,000 to make it into centimeters cubed gives us 56 cm cubed. And finally, we have 1.28, which converts to 1,280 centimeters cubed. So what do we mean by concentration? Well, concentration means how much of a chemical there is in a fixed volume. This can be measured in either grams per dm cubed or moles per dm cubed. In a solution of low concentration, or a dilute solution, you have more solvent than solute, so you have more liquid than the solid that you're dissolving into it. If this is a strong concentration or a high concentration, you have more solute. So the more solute you have per volume gives you a higher concentration. For key skills in chemistry, you're expected to be able to work out the concentration in grams per dm cubed. This gives you this equation. So concentration in grams per dm cubed is equal to the mass of the solute over the volume of the solvent, so grams over dm cubed. We can then rearrange this to work out the mass by doing concentration times volume, or the volume by doing mass divided by concentration. This gives us the triangle on the slide. It is also important to note that grams per dm cubed can be written in the two ways shown on the left-hand side of the slide. So we have 4 questions here. First of all, calculate the concentration of solution of 10 grams of salt in 1 dm cubed of water. So we're working out the concentration, we have the mass, and we have the volume in dm cubed. So we're simply going to do 10 divided by 1, giving us a concentration of 10 grams per dm cubed. For question 2, we need to do a conversion. We have 10 kilograms, we need this in grams, so that is 10,000 grams divided by 200, giving us a concentration of 50 grams per dm cubed. For question 3, we also need to do a conversion. This time we have got our grams as we need them, but our volume needs converting. 500 centimetres cubed is equal to 0.5 dm cubed, so we're going to do 25 divided by 0.5, which gives us 50 grams per dm cubed. For question 3, we have a conversion and a rearrangement. So this time we're looking for the mass. So we're going to do concentration times volume. We've been given a concentration of 12 grams per dm cubed, but we have got a volume in centimetres cubed. 300 centimetres cubed is equal to 0.3 dm cubed, so we're going to do 12 times 0.3. giving us a mass of copper sulfate of 3.6 grams. So in this tutorial video, we have looked at what is meant by 1 mole of a substance. We have calculated the number of moles of a substance using mass and molecular mass, and we've calculated the concentrations of solutions in grams per dm cubed. Our 2 big questions today were how many moles of CO2 are there in 132 grams, and 58.5 grams of sodium iodide is dissolved in 0.5 dm cubed of water. What is the concentration of this solution? I want you to work out these 2 questions now. To help you, the MR of CO2 is 44. So for question 1, we need to do moles equals mass over mR, so 132 grams divided by 44, which gives us 3 moles of carbon dioxide. For question 2, we need to use concentration equals mass divided by volume. From the question, we are given our mass of 58.5 grams and our volume of 0.5 dm cubed. This gives us a concentration of 117 grams per dm cubed. That concludes this video in the Chemistry Key Skills series. In the next video, video 6, which will be the final video in this series, we will look over the empirical formula, limiting reactants, and stoichiometry.